Hello to everyone. I am Professor Raja, working as Assistant Professor EC Department, SNS College of Technology and Autonomous Institution, Coimbatore. In this YouTube video, I am going to discuss about 23 ITT 301 microcontroller and embedded system for the Unit 5 application development for the topic elevator controller. As you are a student of second year computer science or EC students, if you know about how microcontroller is working and how the embedded system is working, then this topic is much more benefit for your mini project or project design, because embedded system is a pure hardware based software control devices, like as I discussed in previous video, the intuitive alarm system. This elevator controller also, based on the input needs, the component will perform on the output. Now we will discuss on the today's topic, elevator controller. First, we have to think this elevator controller in a design thinking based alignment. As you know, design thinking comprises of 5 phases. One is empathize, define, ideate, prototype and test. Empathize means understand the user needs. Define means identify the challenges. Ideate means generate the solutions for whatever we have find out the user needs and challenges. Then prototype, we must set the hardware setup with the sensors, motors and a microcontroller unit. Finally, we have to test their performance. In general, for any hardware devices, the performance can be evaluated by using accuracy, response time, safety, reliability, power efficiency, then cost-wise control. As I told earlier, this topic elevator controller is mainly used in residential and commercial buildings, hospitals with emergency priority, high-rise smart buildings like IoT-based monitoring. Now we can see each topic in individual. Elevator control system in the phase of empathize, that is understand the need. If you see this, for example, if the building owners, they must see from one place to another place, they must see the safety, comfort zone and accessibility. The next, if you consider the case of building owners, the reliability and cost effectiveness is very important, as if you are a maintenance team, the EC diagnostics process is very important. As a society, the energy efficiency is very important. So we have to find the problem with the old lifts, that is the old lift provides delays, jerks and unsafe stops. So as you are engineer, you must conclude these all problems with the new innovative elevator controller. Next phase is define space. So finding the problem space, that is elevator challenges. As you are an elevator designer, the main problem is multiple frequency requests simultaneously, priority handling, that is up and down request, then safety mechanisms, that is door lock and overload sensors, then energy optimization, that is in ideal stage how it uses their energy, then emergency protocols like firing and power cut, then emergency situations like fire or power cut. These cases are very important for considering if you are engineer to design the elevator controller. Next is the ideate part, that is by using a system component, how we can find the solution. The main core components of this ideate system are to find the input, output and interfacing components. First, the inputs are floor buttons, sensors. The sensors mainly used are IR sensor and limit switches. Next, we use the so many processors like microcontroller, 8051, ARM Cortex and PIC microcontroller. The third and very important are output. The output can be delivered by motor driver, display, buzzer, door motor. Next is the communication medium. Communication medium can be carried out by UART, wireless monitoring and CAN bus protocol. Next is we have to maintain the safety. Safety is provided by emergency brake or overload sensor. Next, the prototype. As you are an engineer, this part is very important, that is how can we set up the hardware setup. So as I told earlier, any hardware setup consists of inputs and outputs and an intermediate sensor node, and all these are worked by using the power supply unit. So the inputs, the main inputs of this elevator controller are push buttons, IR sensors for door flow detection. Next is the controller. Here we use Arduino, PIC and ARM board controller for interfacing input and outputs. Then the output, as this is the elevator controller, the main purpose is moving one floor to another floor. So the DC motor with the driver and the LCD, LED display devices are mainly used, and the buses are included. Next, power supply. Here we use the 5 voltage or 12 voltage regulated power supply we are using. Next, evaluation matrices. Here we use the evaluation matrices are 5 important topics as accuracy, response time, safety, reliability, and efficiency. As you are engineer to design elevator controller, the accuracy means to correct floor arrival. That is, if we press second floor, exactly the second floor should be arrived. Then response time, it is the minimum waiting time for each floor. Then safety means door movement from during the motion. Then reliability, continuous operation. Then efficiency, energy consumption, and load handling. These are very, very important if you are identifying the evaluation matrices. So this is the mind map where I have prepared to discuss inside the classroom. Next, this is also the expanded mind map. In the class I have discussed with the students. Then this is the puzzle I have prepared during inside the classroom teaching. The next, these are the references which is used to prepare my PPT of this entire content. Finally, thank you for watching my video. In this YouTube video, I discussed how elevator is working and how they are comprised in design thinking phases. Thank you for watching my video.